Hello everyone, just want to follow up on a few items from yesterday and provide a bit of a reference for people who weren't able to make the session we did. We're going to talk about the altimeter, some of the radios, setting the HSI very quickly, and then we're going to talk about visual trim settings for the Hind, which may help in the hip as well, and also about cross controlling the aircraft. I had a couple of questions about cross controlling the aircraft and how that actually works. So very quickly we'll just go through the controls here for the dash instruments here. We've got an altimeter setting of 760 millimeters of mercury, which should give us about a 10 metre altitude. Just have to adjust it. I know this airfield or this Hind has 10 metres above, so it looks like the altimeter is about 762 on the dial. That could be a parallax error from where I'm sitting. But it's important to get your airfield height dialed in, because all the manoeuvres you're going to be doing are going to be based upon that altimeter height above sea level. We don't trust the radar altimeters. Are useful in certain situations, and I will adjust mine to let me know when I'm approaching the ground. But other than that, the radar altimeter is going to give you your altitude underneath the aircraft, and it's useful in certain situations. But for general aviation flying about the place, I always joke you should treat the aircraft like a very heavily armed Cessna, so you're going to be working off your barometric altimeter for most of the time. With the HSI, horizontal situation indicator, one of the big tips I can give people is using the HSI and this needle here, which is controlled by the course setter, to give you an idea about where the wind direction is coming from. Now, if we look out at the windsock, we can see the wind's coming from the left-hand side. I know from the mission briefing before, this is the wind's coming from about 025. So if we set our needle to about 025, then we can use that as a reference throughout the flight as to where the wind is coming from. DCS obviously has static winds, so it's quite helpful to be able to have that there, so you can work out where you're going to set your landing approaches up. Radios wise, so your front radio here, which is your 863, is generally used as a primary radio for communicating with other flights and as a command channel when we're operating. The JADRO is used by the Hinds for intra-flight communication or intersection communication, and your 828 at the back here is used for communications within the flights. One of the things that people were dealing with yesterday is getting the radio to tune. So if you select a channel, what you need to do is press this button here. Now, both the Hind and the hip have this radio. It's just configured slightly differently. This button is white in the hip and is over on the co-pilot side. But if you press the button, you'll see the green light come on and then go off. So if I do that again, that's the radio tuning to a new channel. And the longer the light stays on, the further that radio's having to tune. So if you select get all the way up, it's going to be on for a little bit of time, because it's having to dial all the way out to that frequency, and then you can let go of the button. So that's hopefully cleared that up. Now, initial trim. It's kind of important to find out in your helicopter where your initial trim position sits, and you can do that by bringing up the controls indicator. Now, for a Hind, the initial trim position, you can watch the nose being dragged back. If I leave it in the centre, the aircraft will go forwards, and if I release the wheel brakes now, the aircraft will start rolling forwards. Okay, so it's important to work out, and if I bring the cycle back, let the aircraft just come to a stop, it's important to work out where your initial trim position is going to be for your aircraft. And as you can see from the controls indicator, if I trim there, let the stick come back to centre, I can now hold, that's at this power setting, holding the aircraft steady. Okay. We generally want to take off and land into wind. So what I'm going to do is I'm just going to take us out onto the elongated taxiway here, just by adding a little bit of blade pitch, so it's about 2 degrees of blade pitch, and then I'm going to slowly move us forward. I do enjoy these new maps. You can see the aircraft responding to the tarmac and the bumps and undulations in the taxiways, which is really quite immersive. So again, looking down at the HSI, we're going to see bringing the nose of the aircraft into the wind, and you'll find the aircraft is so much easier to control when it's facing into the wind. Now obviously this is not always going to be possible. Situations are going to dictate that you land and take off otherwise into the wind at times, but it's going to make your life so much easier for practicing, and it also gives you that feel of how the aircraft responds when doing the TLA. So when we're taking off, we apply plower and then we retrim. Okay, so we're going to add more blade pitch and we're going to watch what the helicopter does. Okay, now it wants to move backwards, so we're going to apply a little bit of forward cycling, retrim, apply more power. Quite light today, so I can feel the aircraft becoming light on wheels already, but we're going to look to what the aircraft wants to do, stabilise it, and we're going to retrim. And we're going to keep applying power until we're quite happy with what the aircraft's doing. Obviously you can see me feeding in anti-torque pedal, so again it wants to move backwards, retrim. We keep just finessing the trim until we get it into a situation where the aircraft is stable and will lift off the ground. And it should go straight up. And then you go into your normal hover checks. Okay, so your normal reference-based hover checks, so looking out the left and right of the window, looking at your ground references and keeping the aircraft stabilised. Now, I tend not to trim in the last few degrees before I lift the aircraft off. That's because I like to have a little bit of pressure on the cyclic away from its centre detent. I feel it gives me a little bit more control of the aircraft. Notice I'm not in any hover modes or anything like that. And it allows me to just, at the moment I have 2 fingers and my thumb placed on the cyclic, my forearm rested on my thigh, and I'm just holding the aircraft in place. Okay? So when we talk about cross-controlling, we're talking about the ability of the aircraft to be translated in more than one axis at once. What do I mean by this? Well, we all know we can move the aircraft forwards or backwards. Okay, you just dip the cyclic or bring the cyclic back and the aircraft will travel. But the aircraft will also slide sideways. So if I let the cyclic go left and I leave everything where it is, the aircraft will stop moving sideways. Bring it back to centre. And if I bring the cyclic right, all else being equal, the aircraft will slide to the right. Bring it back to centre. Now, what this means in reality is that we can move this aircraft laterally whilst travelling in forward flight. So what does that look like? Well, I'll bring the aircraft off the ground here and I'll show you. Of course, I'll leave the controls indications on so people can see what's being done with the aircraft as we fly around. Now there is a bit of weirdness with the Hind's trim. When you do trim, it does take some of the autopilot out, so you'll notice sometimes the nose will want to dip. Just be prepared to catch it as you fly around. If you do trim, just be aware that that's a thing that the aircraft's going to do from time to time, and just be prepared to catch it. Depending on your controls setup, the method for this may differ, so I'm not going to go too deeply into that at the moment. Also, don't be afraid to use the bump trim. You know, the Hind's got a bump trim for a reason. It's very useful, and it can be used to just finesse that little bit of control, and also when formation flying and things like that. So what I'll do is I'll clear us left and I'll bring the aircraft round to the left hand side, and in turns what we're trying to do is keep the turn ball centred. We're going to stop our ascent, looking down the ADI. We're trying to keep that turn ball nice and centred so we're aerodynamically in trim, and this will stop the variations in airspeed that you can get when you're trying to turn the aircraft. You know, if you notice your aircraft suddenly loses speed in the turn, it's probably because your slip ball's out and you're dragging the aircraft through the air. Also with the Hind as well, kicking the rudders out, depending on your microswitch settings, overcomes the autopilot channel and stops the autopilot trying to keep the aircraft on heading. So if we're flying down the beach now, what we can do is we can slide the aircraft. so we can cross control. And what that means is I'm going to apply cyclic input and opposite rudder. So I will apply left cyclic and right rudder, so the nose continues to be on line. The aircraft is now going to slide, translate to the left. Okay, so I've changed the vector of the aircraft, the flight path of the aircraft, whilst continuing to maintain the same attitude. And if I want to stop it, bring the aircraft to level, arrest the move, arrest the motion, and then bring the rudder input out. Okay. And if I want to take it back the other way, roll the fuselage to the right, put it in left rudder, left anti-torque, let's keep the nose of the aircraft on heading, allow the aircraft to slide and translate one way or the other. Now you'll notice the vertical speed indicator, because I'm now putting pressure, aerodynamic pressure on different areas of the disc, some areas that are generating more lift, some areas that are generating less lift because they're in forward flight. That's going to cause the aircraft to want to climb or descend, so you do have to adjust a little bit of cyclic as you complete these manoeuvres. The asymmetry of lift mandates it. So in the Hind, why is this useful? Well, we can do something. The Hind's got a very long nose, right? If I come in high on a landing pad, I've got a lot of aircraft in front of me, and that can cause us a problem. So one thing we can do is we can use this to boot the nose of the aircraft out in order that we can see essentially underneath the nose. So what I'm going to do is I'm going to show you how that works now. We're going to attempt to land back at the landing pad on the far end of the airfield here that we took off from. Essentially conducted a brief little left traffic pattern. So as we come into the landing, so we want to check our gears down, checking light conditions to make sure all our lights are running when we need them. And we're going to look to slowly decelerate the aircraft and start a descent into the pad. Bringing the aircraft into the wind. There we go, nicely into the wind. And we're going to retrim. Get a nice initial trim position, catch the autopilot release, and then retrim the aircraft and allow the speed to slowly reduce. Bring in a rate of descent, so that's a 1 metre per second rate of descent at the moment we've got him. And the speed's coming nicely down, and obviously we can finesse that using the beep trim. Now if I feel like I'm not going to be able to see, I'm going to lose visual of the landing position, I can cross control the aircraft. So if I apply right anti-torque pedal, left cyclic, you see the nose of the aircraft comes round, but my flight path stays the same. So I'm now flying where I'm looking. Flight path vector is off on the left hand side of the nose, and I can see all the way down in front of me. Nothing else has changed. The rate of descent's still there, the speed's still there, but I can now see the landing pad. And as we start to descend into the pad, we can start to bring the collective back and start to look to retrim the aircraft so that we can attain a stabilised hover when we land, terminate to the hover that we want. Now, another really good thing about this, about doing it this way, is that as you add collective to terminate, your nose will naturally want to come round to the left again. So as we start adding collective, it's going to bring the nose round to the left, let it come round, let it come round, let it come round, and now when we're about on line we can start feeding in that anti-torque. And there's my altitude warning. We're going to look again. Now you can either retrim now or you can not and just hold the aircraft as it is. Going through ETL, in ground effect, bring the aircraft back online, and then bring the aircraft into a stabilised hover, right back where we started. Okay. From there, you can either choose what you want to do. You can either recommence and go for another pattern. Just catch the drift. There we go. Or we can look to bring the aircraft back down to the floor. And bringing it down to the floor is the reverse of taking off. You just want to go very slowly. So I'm going to very, very gently start removing collective. Very slowly, and just watching what the aircraft's doing, just catching any movement or drift until we can start feeling wheels touch the floor. It's a wheel, right side, left side, and that's the aircraft down on the floor again. I hope this has been helpful to you. If people have got any questions, please let me know. Yeah, have a good flight. Hope to see you soon.